Alright, hi guys. So today we're going to look at forming what we would call a linear sequence. Now a linear sequence is a special kind of sequence that has what we call a linear pattern. And the reason why we call it a linear pattern as opposed to a different kind of pattern is because linear, as you probably know, means something that's straight. It means like a line. So if you imagine a straight line, if we look at this one here, what makes this a straight line is that you're always increasing by, if you imagine some stairs, like going up a set of stairs, you're always increasing by the same amount every time. Okay, so if we imagine this is 2, so you're adding 2, you're always adding 2 to get to the next point. Okay, that's what makes it straight. If it was a curved, then your stairs might look a little bit different. Okay, you might have some that are smaller and some that are really big, like this one here. Okay, so they're not increasing by the same amount. So a linear sequence, very important. The values always change by the same thing every time. Okay, and a lot of these we've been looking at already, just kind of without you knowing it. So same as normal, I want you to kind of write down everything that's on this page, and we'll get started. So firstly, a little bit of a revision from the other day. What sequence does 5n give? So we're going to write the first 5 terms of this sequence. Okay, we're going to start off where n is 1, so that'll be 1 times 5, which is 5. Okay, second one is where n is 2, so 5 times 2 gives us 10. Okay, third one is where we've got 5 times 3, so that's 15. Fourth one, 5 times 4, 20. And last one, 5 times 5, 25. Okay, and this is a linear sequence because every time we're increasing by 5, okay, we're going up by 5 every time we go to the next number. All right. Next one we're going to look at is 5n minus 4. So 5n minus 4, again, if we just take away 4 from each of these, that's going to give us the new sequence. So if we do, so 5 times 1 is 5, 5 minus 4 is 1. So our first one is 1. 10 minus 4, right, that's 6. 15 minus 4 is 11. 20 minus 4 is 16. And 25 minus 4 is 21. Okay, now if we look at this again, we're still, if we're going from 1 to 6, we're going up by 5. 6 to 11, we're still going up by 5. 11 to 16, we're still going up by 5. So every time we're increasing, we're still increasing by 5. So that should tell us that the fact that we've got this times by 5 at the front here as a coefficient of this n, that's something that's quite important. Now we can see if we weren't adding or subtracting anything, we would expect that our first term would be 5. Because we're starting off, we've got that 5 times 1, and that gives us 5. Now for this first one, for the next one, because we've got 5n minus 4, our n is still 1, so we've got 5 times 1, which is still 5, but then we're taking away the 4, okay, which is just leaving us with 1. All right, so that's really important. So lastly, what do we notice about the difference between the terms? You're still subtracting, what am I talking about? Subtracting. You're increasing by adding 5 each term, okay? Now, therefore, what do we think would be the difference in the terms? So if we're looking at a sequence that was 6n plus 2, what would we think the difference would be? So let's have a look at the first 2 terms for this. So if n is 1, 6 times 1 is 6, plus 2 is 8. 6 times 2 is 12, plus 2 is 14. Okay, so if we look at those first 2 terms, now the difference between 8 and 14, that's 6. Perfect. And we can see there, we still have a 6 here. Okay, second one, n minus 1. Now, if n, again, we'll look at the first 2. If n is 1, 1 minus 1 is 0. Okay, if n is 2, 2 minus 1 is 1. Okay, so our difference in this case is 1 between our terms. And we can see that there, 0 and 1, that's 1. Now, what you'll notice here, remember from algebra, we don't write 1n, we just write n. So this actually has like an imaginary 1 out the front there that you just can't see. Okay, this one, hopefully you're catching on, we would expect the difference in this one's going to be 10 because that's 10n. So we should have a 10 there, right? But let's just do the first 2 just to check. So 10 times 1 is 10, minus 3 is 7. Okay, 10 times 2 is 20, minus 3 is 17. Okay, so again, we've got a difference of 10 between 7 and 17. Next one, 3 minus n. Okay, again, now this one's minus n. So I would expect instead of adding, we're going to be minusing 1, because again, there's no number out the front, and that's negative. So let's work it out. So 3 minus 1, that's 2. Okay, 3 minus 2, that's 1. So again, we're decreasing by 1 in that scenario. Okay, so what we're going to do now is we're going to move on to how we can find the rule if we're given a couple of terms. Okay, so scroll down with me and we'll have a go. So a couple of things that are important to think about when we're trying to find a rule. The first one is all of your linear sequences have this form, an plus b. So that's you've got your timesing n by something, and then you're adding or subtracting something on there. So just be careful there that b can be negative. You don't always have to be adding, you can also subtract. Now, the important things to look for are what's the consistent change in the values and what you would need to do to go from that change to the starting term. Okay, and I'll explain this second bit on a bit more in a second, because that's probably the hardest bit. So if we look at this one first, now if we're going from 7 to 12, we are adding 5. 12 to 17, we're adding 5. 17 to 22, we're adding 5. And 22 to 27, we're adding 5. Okay, so we've got that consistent change of 5. So that means for our first one, that a value, I'm just going to write it down here for 1, a should be equal to 5. Okay, now our first term isn't 5 though, it's 7. So we must have done something to go from where n is 1 to make that a 5, to make from when n is 1, from making that a 5 to making it a 7. So what have we done to go from 5 to 7? Well, we've added 2. Okay, so in that case, our b value should be 2. Okay, so let's try it. So our formula is 5n plus 2. Now, if we just try with the first two just to check that we've got it right, okay, n equals 1, that's 5 times 1 plus 2, okay, which is 7, where n equals 2, we've got 5 times 2 plus 2, okay, that's 10 plus 2, which is 12, okay, and that's perfect because they're the first two terms that we have there. All right, excellent. Let's try the second one. So the second one, okay, we're going from 5 to 7, so we're adding 2, 7 to 9, adding 2, 9 to 11, adding 2, 11 to 13, adding 2, perfect. Okay, so we're thinking that our a value, we're changing by 2 every time, so a is going to be 2. Okay, b, now we've gone from 2, if n was 1, then we'd expect 2n to be 2, but we're actually starting at 5, so we're going to have to have added 3 to get to that 5 as our starting point. Okay, so therefore I reckon our sequence is going to be 2n plus 3. Now let's try it. When n is 1, okay, we've got 2 times 1 plus 3. 2 times 1 is 2 plus 3 is 5. Okay, n is 2. We've got 2 times 2 plus 3. Okay, it's 4 plus 3, which is 7. Perfect. Excellent. That's what we want. All right, let's go for the third one. All right, I'm going to do the third one, and then I want you two to try. I want you guys to try the last two yourselves, and I'll put up the answers. Okay, so for the third one, we're going from 2 to 5, so we're increasing by 3. 5 to 8 by 3. 8 to 11 up by 3. 11 to 14 up by 3. So in this case, our a value is going to be 3. Okay. Now, a little bit tricky here because we're starting at 2. So to go from 3 to 2, we haven't added with minus 1 to get to that starting point. So I think that our formula in this case is going to be 3n minus 1. Okay, let's try it. N equals 1. That's 3 times 1 minus 1. 3 times 1 is 3, minus 1 is 2. Okay, try when n is 2. We've got 3 times 2 minus 1. Okay, 3 times 2 is 6. Minus 1 is 5. Perfect, that's exactly what we've got there. All right, I want you guys to try these two. I'm going to put up the answers, and then again, you're going to have a bit of work to do after that. All right, pause the video and come back to it to check your solutions. Okay, all right, cool. Okay, so I hope you've had a go at those last two yourselves, and for the answers, we are, in this case, we're increasing by 6 every time. Okay, so for the fourth one, A is equal to 6. We're starting at 4, so we've subtracted 2 for the B value. So our formula is 6n minus 2. Okay, and for the fifth one, and you can check that one yourselves, you should be able to do this fine. Now for this next one, we're decreasing by 2 every time we go down. Okay, so A is minus 2. Now B, a little bit trickier. To go from minus 2 all the way up to 10, we've had to add on 12 to get there. Okay, so if you imagine that when n is 1, you would expect to have minus 2, but you've actually got 10, so you've had to add 12 to get from minus 2 all the way up to 12. Okay, so our formula should be negative 2n plus 12. Okay, that's your answer for that one there. All right, I want you to go on, please, and now do another Google form sheet. This one, the multiple choice one, and on finding linear sequences. Okay, and that should be everything for today, and I'll catch up with you tomorrow on Teams. All right, okay, cool, bye.